some time. Hopefully you can see my screen now. Hi, everybody. My name is Cindy. I'm the data scientist from SAS Canada. So today, if you're a student, just give me a show of hands. How many of you are actually students that's participating? OK, lots of you. OK, time to wake up now. Time for me to show you how to get started with VIYA. I'm going to give you a quick tour around VIYA to help you to get started. I'm going to show you first how you can access VIYA from our programming interface, either through SAS Studio or through Jupyter Notebook. I'm just going to show you Jupyter Notebook because I'm not a good SAS, not a good R programmer. I'm a Python programmer myself, so let's not get into the Python versus R debate. I'm also going to show you, for those of you who likes to look at data visually, who likes to visually explore the data, how to access VIYA from our visual interface. Then I'm going to show you a quick example of building a predictive model using real-life data. So let's get started. So this is the landing page that Steve just mentioned. We changed it up a little bit. Sorry, I didn't update you. We changed it up yesterday because now you have 4 tabs there. So those are the 4 ways that you're able to access VIYA. So first way is you access it from SAS Studio. It's basically our web browser-based interface where you can access VIYA anywhere. So just log in there with your username and password provided to your team. It's loading. OK. So this is the interface you're going to arrive when you log in through SAS Studio. If you are a SAS programmer, you're able to write your SAS program here and call your procedure. And it will do your auto-completion, and it will also bring up the documentation. So if you need help on how to program in SAS, you can get a lot of help from there. Also, Steve just talked about the tasks. So tasks are like the wizard-guided examples and procedures you can do. For example, if you want to do a summary, it will guide you through. You can specify different options, and it will actually generate SAS code on the right-hand side. So if you want to learn, say, how to code in SAS, you're able to just copy and paste the code, make slight modification to the code. We also have snippets. So snippets are actual code snippets that you often use. So if you say, for example, to connect to VIYA, so I just want to give you some background knowledge of VIYA. So you can think of VIYA as a platform, and then SAS, our cloud analytics services, is actually the engine behind the platform. So it's like it's an in-memory, multi-threaded engine that's driving behind the platform. So when you connect to VIYA, you are actually talking to SAS to leverage the computing power. So what you can see here is you probably want to declare a new SAS action. I'm just quickly going to create a new program here. And if you want to use, if you want to know how to create a new SAS session, you can quickly insert the code snippets here. So, and also, if you want to terminate a session, you can quickly insert the code snippets here. So you can also create your own code snippets. For example, my coworker created a code snippets for loading Excel into SAS. So if your team has your code snippets that you want to share that are often used during your project, you can just save it in your own snippet, and you're able to use it and share it amongst your team members. Now I'm going to show you, for those of you who are not SAS programmers, how you can access the power of the SAS engine through Jupyter Hub. It doesn't have to be Jupyter Hub, by the way. It can be any Python IDEs, doesn't matter. But we have Jupyter Hub here. So I'm going to quickly show you. So this is the Jupyter Hub you guys will log into. It also needs your username and password. So if you look here, you're going to import the SWAT package, which is just like any other package. For those of you who are familiar with Python, it's a little bit like PySpark for Spark. And then the fourth thing you need to do is to make a connection to the CAS in-memory engine, and then start it a session. Then you can load your action sets. So what action sets are basically the functionalities, the classes in CAS. So you can choose different action sets to load. For example, in this case, I'm choosing my sampling action sets, my neural net action sets, and then you load your action sets. I'm just going to quickly show you a syntax of calling a SAS action. So the basic syntax of calling a CAS action is you specify your object, you specify your class. So I'm calling the data process class, and then I'm calling the methods imputation within the class. So it's very similar to all your Python syntax. It's like how you would call any package, and you have the parameters inside. So if you want to, utilize the power of CAS through Python interface, you can. Now I'm just going to quickly show you, if you are not a programming person, or if you want to visually just take a look at your data first, then you can access the SAS Visual Analytics, which is our visual interface. This is something that I really recommend you to do before you start playing around with the data. Take a look at the data first, because with real-life data, there can be lots of data quality issues. There can be weird things happening with the data. It's always nice to get a sense of what the data look like and what you can possibly get out of the data through a visual interface. I'm just going to give you a bring up something that I built for the Toronto fire. So anybody, just to give you some background. So October 13th, next Friday, it's the International Day of Disaster Reduction. And City of Toronto is actually hosting a 2-day hackathon at 1:11. So the purpose of this hackathon, just like this challenge, is to use technology to help the city to make better decisions, to help the city to prepare for disasters when it comes. And SAS was part of the sponsor. So we were asked to show them a little bit, because unlike you, a lot of you probably have a quantitative background, but a lot of people that are actually participating in this hackathon are firemen or policemen. We just want to give them a quick demo of what you can possibly do with data. So I'm just going to so the data that I took is from the Toronto Open Data Portal. So when you are doing your challenge, you probably will go to outside data sources to get more data. And the thing with outside data sources is they're not in the format that you guys are familiar with. For example, the fire service incidents data, it contains all the 911 calls to the EMS services. It's in XML format, and you have to parse through the XML. For example, another data set that I looked at is the fire station location, the intersection that contains all the road intersections in City of Toronto. It's actually in a map format called WGS84. If you guys are in GIS, you guys are probably familiar with that format. So with these data, you guys need to do a lot of, you are loading data from your unfamiliar data sources. It's not a CSV anymore. So what I did is I did a quick overview of the data set, of the Toronto fire incidents data set. And you can find some insights very quickly just by looking at it visually from the data sets. For example, on this plot, I'm plotting all the incidents over the year 2013 to 2016 it has 500,000, more than 500,000 incidents. And you can see here, like, just by looking at the time series, it's the seasonality component is not very obvious, but the events, the special events, is actually what drives the number of calls. So if you look here, this is actually the winter storm that happened in 2013. And if you look at the second peak here, this is actually the flood that happened in 2013. I don't know if you remember, but I remember because I was stuck on the GO train for 8 hours that day. So, and this is like a quick overview, quick view of the reason for people to call EMS. And surprisingly, or not surprisingly, concerningly, one of the top reasons is actually alarm system malfunctioning. So that makes us think about, how do we allocate the resource? And you can also quickly see that, the number of calls varies greatly by the incident hours. And also, you can have a visual overview of actually where the calls are coming from. So this plot shows all the calls, the 500,000 calls that was calling the Toronto EMS. You can see it's very dense here. So you can give a very visual representation of the data. You can also have a quick correlation matrix with the variables. So that's our visual interface. With this being said, I was giving a very, very broad question, right? How can you utilize technology to help better prepare for disaster? This is the same question that you guys are given in the food security challenge. What can you do to help? In order to deal with this kind of problem, you have to narrow down the scope. It's always nice that we make a billion dollar solution, or we always think about, oh, we can make this model that saves the world. But that's not actually the case, right? When you have limited time and limited resource, focus on one problem, on one little problem. I had 2 days to work with this data, so I focused on one problem. So I built a model to predict actually how many minutes will it take for the EMS to actually arrive before you make a phone call. So I was thinking, if it takes 2 hours for the EMS to arrive, I probably won't bother call. I will go to the hospital just by myself. So this is the problem that I wanted to take a look at. So now I'm going to show you how I actually do it. So I'm doing this through the SAS Studio interface, through the programming interface. Like I have mentioned to you, a lot of the data available in the open data is very messy. You have to clean it up. So for example, I had to load the map data into SAS. So I used the procedure called map import to load map data into SAS. And I also had to do lots of data preparation. You see, that's probably the code that the time you will spend most doing data preparation. 80% of your time will be doing data preparation. And then I had to join multiple data sources. So some of the data sources that I looked at is the intersection data that I mentioned. I also look at the Environment Canada data of the weather hourly data. So that's some data that you guys probably interested to look at. I think the weather data probably have an impact on food as well. So and then I'm going to show you, to build a predictive model, I want to leverage my computational power of our cloud analytics services. So to do that, I just simply load my data into SAS. And you can see here, I just need to, I missed a C there. Now, I can see it has been loaded to my SAS library. And then, I can quickly use my task to do a quick summary of my data. For example, for this table, the variable that I want to look at is the variable that I created with expected time of it takes for the EMS to arrive. So if you look here, this is number of categories in the expected time. You can see here in the category where it takes more than 15 minutes for the EMS to arrive. It's a very rare event. So when you do model real life data, rare events is a very common situation. For example, I'm actually a Scotiabanker. I was doing a lot of credit risk modeling. For example, the delinquency rate, the default rate, the write-off rate is actually a rare event to model. So to do that, you have to, for example, oversample the data. I can do this easily using VIYA. This is the data set that I used. I want to do oversampling. And I also want to filter. Why do I want to filter? Because when I was doing data exploration, I realized there's actually where the fireman arrived before the call was even made. So that's a data quality issue that's only available on the open data. With school data, you never see these kind of issues. I want to oversample by not this one, expected time. And we'll pick up the oversampled event level. So my target event is more than 15 minutes because that's my rare events. And you can see here, the code is automatically being populated. So next time, if you want to just use the code or tweak a few things, you can change it here. You can change the code as well. I'm just going to make it less rare, so it consumes 20% of my sample. You guys are probably familiar with this already, but just show you how easily it is done. So then I oversampled my data. Now my data is in a position where I can apply a model. For example, a very common model, you can see here there's lots of common machine learning algorithm. A very common model for me to do classification is I would use decision tree. I want to use my sampled data, and I want to have a validation data set, 0.3%. You can specify all your details here. And it will also tell you that what things you are missing in order to write a model. So it's very smart. It knows what you're missing. And I want to pick my interval inputs. It automatically filters out my interval inputs, so I don't have to go through my hundreds of variables. Here, I can specify my options. There is a little box here that I don't want to check. This is called automatically tune selected options. This little box, I think it will take away the fun of modeling because this allows you to automatically tune your hyperparameters. So if you have built a model, the most amount of time when you spend on model building, on the actual model building, is probably tuning the hyperparameters. What are hyperparameters? Those are the number of hidden layers in the neural network or number of leaves in the decision tree. With SAS, I think SAS intentionally hide it here. It has actually, for the VIYA, has this auto-tuning method that will automatically parallelly test out different combinations of hyperparameters and optimize the hyperparameters so it gives you the best model. So that's like my job. So I don't want to show it to everybody. So that's taking away my job. So let me uncheck it now. And just, I'm going to, I know how to change it because I'm a data scientist. These are I can pick what plots I want to show. I can save my scored table. And poof, I've built a decision tree in just few clicks. Takes some time to run. And I can take a good look at my decision tree here. You can see here just from the color coding. So the blue one is when the EMS arrive in less than 15 minutes, and the red one is when they arrive in more than 15 minutes. So you can see the tree did a pretty good split. The purity is pretty good. And then if you actually go down all the way down to the variable importance, surprisingly or not surprisingly, the most important factor affecting how many minutes it takes for the EMS arrive is the number of incidents that's happening 5 minutes prior to your call. So that alone can help them to better plan their resources. Also, what kind of response are you telling them? Is it a medical call? Is it a fire call? Also, the distance you're away from your nearest fire station. Also, the relative humidity. That's like if the humidity is high, probably it's raining. That's why it will take the EMS longer to arrive. So it's you can see it's a very you're able to interpret the result. And also, if you want to assess the outcome of the model, for us in risk, we usually use a lift chart. So you can do it quickly in VIYA. So I just bring in my scored data set, and I pick my target variable, which is expected time, and my event is more than 15 minutes, and my posterior probability is this one, and I just want to select, just to make the curve looks a little bit nicer, I want to look at my cumulative lift chart, and it will give me a very nice plot on my result. So if you can see here, I have a nice AUC of 0.9. I have a nice cumulative lift chart. So with that being said, it's a very simple model. It's a that simple decision tree model. But with a very simple model, with the right question to ask, you can come up with a solution that can help to solve a problem. So for this kind of challenge, really, when you're dealing with data, for this kind of challenge, the most important question to ask is, what problem do I want to solve, and what question do I want to answer? So that concludes my demo. Hopefully, you got an understanding of how you can use VIYA. All of these are documented in our GitHub repository. So if you want to take a look, and if you run into any issues while you're working with VIYA, you can also open an issue ticket on GitHub, and we will respond to you as soon as we can. Thank you.
So thanks, Cindy. And I think there's a couple of things I wanted to highlight from Cindy's presentation that I think will help you. First of all, document where you're getting your data from. There's a lot of data out there. The data is messy. The world is messy. Document what you're getting, get where you got it from. I think that's going to be one of the things the committee looks at and says, where did this data come from? Is it a reputable source? Did they get creative in terms of how they were pulling in new sources of data? And the reason we had Cindy do that was to show you the process that she went through, right? She pulled this, she tried this, she did this. Some of the coding that she showed, that's with SAS programming. We think that the wizard makes it a little easier to do things, but you can bust out code and with a blinking cursor get going on it. That's okay. I think the ability to think outside the box will only help your score, okay? So think about new challenges and things. Just a little vernacular thing or a little terminology thing. We are SAS, the company. The product name is VIYA. And Cindy referenced a couple things that I just wanted to clarify. She used the word CAS. CAS is our engine. So if VIYA is the product, CAS is the engine inside the product. And you call CAS or VIYA through a thing called an action. Cindy mentioned the term action as well. So as you look through the documentation, all of our documentation is available. We've created some quick start guides and some sample code that we've published to the GitHub. But if you hear the term action, it's basically an API call or a call. If you hear the word CAS, that's the engine that's executing it. And pretty much every journey you start with VIYA begins with connecting to CAS. Okay? So that's just a little nomenclature thing for you. And I think that was about it. I think for us, what the VIYA platform and what we're doing is helping to enable everybody to use the same data, the same science, and the same platform. Again, this is where the marketing guys kicked in. And whether Cindy did that work with SAS Studio, or she did it in Python, or she used the visual interfaces, you're going to get a fairly similar experience. Obviously, there's some tuning and parameter differences, but you can get at it a bunch of different ways. And if you've known SAS for a while, that's a new thing that we've been doing. And just to close, I think that was basically it. And yeah, this is again the marketing, but we've basically given you guys this diverse set of capabilities to help you scale your analytic challenge and deliver some interesting things to the organization. So again, sorry for the marketing slide, but we are the trusted name in analytics. Marketing made me put that in there. So with that, I think I'll hand it back to Dean, who will take you through the next piece. Thanks for your time.
Okay, perfect. Thank you very much, Steve and Cindy.